Problem 124. According to a car dealer sales report, 1/3 of the cars sold during a certain period were sedans, and 1/5 of the other cars sold were station wagons. So 1/3 of, let's say, the cars sold, so the total, were equal to sedans, and 1/5 of the other cars sold were station wagons. So 1/5 of the remainder of this, so that's 1/5 of the 2/3 cars that weren't sedans. So 1/5 of the 2/3 of the total were station wagons. Let's call it W for wagons. If n station wagons were sold during that period, okay, so W is equal to n, how many sedans in terms of n were sold? All right, so we know that 1/5 times 2/3 times the total is equal to n. And actually, even better, let's just substitute s for t. So let's see, if we multiply both sides of this top equation times 3, we know that the total is equal to 3 times the number of sedans. So let's substitute that here for t. So you get 1/5 times 2/3 times 3s is equal to n. See, 3 cancels out. 3 divided by 3. So you have 2/5 s is equal to n. Or, let me just write it up here. So multiply both sides by 5/2. You have s is equal to 5/2 n. And that is choice D. Problem 125. 125. If P over Q is less than 1, and P and Q are positive integers, which of the following must be greater than 1? So think about this. If P over Q is less than 1, that tells us that P is less than Q, right? You can multiply both sides of this times Q, and you get that. P has to be less than Q. And they're both positive integers, so nothing tricky here with negative numbers. So just the instincts, which of the following must be greater than 1? I don't know if this is going to be a choice, but if this is less than 1, if you invert it, it's going to be greater than 1. So Q over P is going, divide both sides of this by P. You'll get 1 is less than Q over P. And that makes sense. If 1/2 is less than 1, then 2 over 1 is going to be greater than 1. If 2/3 is less than 1, then 3/2 is going to be greater than 1, right? So if P over Q is less than 1, then Q over P is going to be greater than 1. And we did it algebraically by just multiplying both sides by Q and then multiplying both sides by P. I don't know if that's yep, that is a choice. E, Q over P. That made it easy. I thought I might have to do more work if that didn't show up. So Q over P is definitely greater than 1. Next question. 126. It would take one machine 4 hours to complete a large production order. So machine 1, it would take 4 hours. 4 hours. So you could say one order every 4 hours, or 1/4 order per hour. That's machine 1. And another machine 3 hours to complete the same order. So machine 2 does one order in 3 hours, or 1/3 orders per hour. How many hours would it take both machines working simultaneously at their respective constant rates to complete the order? Okay, if they're working together, you're going to have one machine producing at 1/4 order per hour, plus another machine producing at 1/3 order per hour. So their combined rate is going to be what? Over 12, and then 1/4 is the same thing as 3/12, and 1/3 is the same thing as 4/12. So their combined rate is going to be 7/12 order per hour. And you want to know how long is it going to take them to make one order. So you could think of production is equal to rate times time, and time is equal to production divided by rate. Or if you don't want to think about them, just think, oh, well, if I can make 7/12 orders per hour, if I had to make one order, it's going to be one order divided by 7/12 order per hour. And this might seem a little confusing to you, but if these were constant numbers, try to play with it. If I had to make 10 orders and I could make 2 orders per hour, then you'd say, oh, I just divide 10 by 2, should be telling me 5 hours. But it's just a little bit more confusing when when I have to make one order and my rate is 7/12 orders per hour. But hopefully, if you substitute whole numbers in your head, it makes a little bit of sense. So this is the same thing as 12 over 7, and then of course the orders cancel out and you end up with hours in the numerator. So 12/7 hours, or 1 5/7 hours. What do they have? Yep, that's choice C. Choice C. Question 127. 127. To mail a package, the rate is X cents for the first pound. So X for 1 pound. And Y cents for each additional pound. Y for additional pound. For each additional pound. Where they tell us that X is greater than Y. 2 packages weighing 3 pounds and 5 pounds respectively can be mailed separately or combined as one package. So 3 pounds and 5 pounds as one package. Which method is cheaper and how much money is saved? Okay, well, let's think about it. If you keep them separate, how much are you going to pay? For the 3-pound packet, you're going to pay X for the first pound. And then you're going to have 2 pounds left that you're going to pay Y at. And then for this one, you're going to pay X for the first pound, and you're going to have 4 pounds left, so plus 4Y. So when you add them together, your total expense is going to be 2X plus 6Y. That's if you mail them separately. Now, if you combine them into one 8-pound package, what do you have? You have to pay X for the first pound, and then you have 7 pounds less that you're going to pay for Y. So it's going to cost X plus 7Y. So we know. So first of all, we know that this is going to be more. Why do we know this is more? Because essentially, we're taking one of the Y's, and when you pay them separately, for that 1 extra pound, that here you're paying it as in X cents instead of Y cents. You're paying in this case, and X is more than Y. And that'll hold out when we actually subtract the 2 out. So let's just work from the assumption, or actually, hopefully you understand the reasoning why this is going to be larger, because X is greater than Y. So let's figure it out. What's the difference? This is the higher number, and let's subtract out the lower number, minus X minus 7Y. I just subtracted X plus 7Y. And that, you end up with X minus Y, right? 6 minus 7Y is minus 1Y. So X minus Y. And the fact that X is greater than Y lets you know this is positive, so that also tells you that this is the more expensive of the alternatives. Separate is the more expensive. And the difference is X minus Y. So they ask which method is cheaper. So the combined method is cheaper. The combined method is cheaper, and you save X minus Y cents. So combined is cheaper, and you save X minus Y cents. And that's choice A. Choice B, they say combined is cheaper with the savings of Y minus X. But Y minus X is going to be a negative number, so you can't say you saved a negative number. They tell us that X is greater than Y, so that you could cancel that out. And anyway, and the other ones don't make any sense at all. Next problem, 128. 128. If money is invested at R% interest, compounded annually, the amount of the investment will double in approximately 70 over R years. Okay? Okay, so you double in 70 over R years. Fair enough. If Pat's parents invested $5,000 in a long-term bond that pays 8% interest, so 8% interest, compounded annually, what will be the approximate total amount of the investment 18 years later as Pat is ready for college? Okay, so let's see. It doubles every 70 divided by R years, where R is 8. So let's see how long. We're just trying to, they gave us that information. Let's try to use it. So how long does it take to double at an 8% rate? So it's 70 divided by 8 is equal to what? It's equal to 8.5. Right? Every 8.5 years, is that right? Yeah, 8 goes into 64. No. 8 goes into 70. 8 times 64. 8 goes into 60. 7 times 7 times 8 is 56. You have a 40. 8.75 years. So just using there, this is going to be exact, but you're going to double your money roughly every 8.75 years. If using this formula they give you at an 8% interest rate. And they say, well, what will be the total amount of the investment 18 years later? So 18 years, that's roughly 2 doublings, right? So you're going to start with 5K, and after 8.75 years, you're going to be at 10K, right? You're going to double in 8 3/4 years. And then after another 8.75 years, you're going to be at $20,000, right? This isn't exactly 18 years. This is closer to, well, this is 17.5. But that's about as close as we're going to get. So in 17.5 years, you get to $20,000. They're asking 18 years, and this is all about approximation because they don't want you to do some hardcore exponent math here. And so the answer is A. I mean, if you look at that 8.75, that's roughly you're doubling every 9 years. They ask us how long, so you could say, oh, after 9 years I'm at 10, after another 9 years I'm at 20. So after 18 years I'll be at $20,000. And I'm all out of time. See you in the next video.